In this video, we are going to be picking pre-stack time migration velocities. So first of all, we'll need to generate a bunch of constant velocity migration stacks. So we'll need a shot gather with all of our statics and processing flow applied to use as input. So here I've opened up the prep module and I've loaded in some shot gathers that have my refraction statics applied, and in this case it's got surface consistent decon applied as well and some other processing sequence. You can start from the raw shots and apply your own processing sequence here if you like. In my case, the only thing that I had left to apply additionally was the reflection residuals. So I'm applying the reflection residual correction here. That's this file here. And I have to specify my floating datum so that I'll populate bytes 53 and 57 in the trace header. And I'll specify the replacement velocity. So in my case, I've already run this job. I've generated this file that I've called input to PSTM. It's a shot-based gather. So I've already run that job. And now I'll go to the VT-cube module. And since I've already run this, I will load in the parameter file that I used to generate my constant velocity migrations. In my case, I input the shot gather input to PSTM, and I have to specify the final elevation, final datum I'll be using in the replacement velocity. So the NMO migration will be performed from topography, but then the data will be hung at the final datum. I've specified here. And the parameters here, I'll be using all of the shots. I'll be creating constant velocity migrations from 1,500 meters per second to 5,000 meters per second every 50 meters per second. So you can fill in the appropriate parameters here. One thing again to keep in mind, under advanced settings, the default is to output the traces here at the receiver interval. You can modify that if you want to output traces at the CMP interval. Typically, for most cases, outputting traces at the receiver interval is a reasonable thing to do. Save a bit of time. I'm going to run this job over, select some nodes to run the job on and the number of cores per node. And then I'll go ahead and run this file called qtvtcube01.segy. I've already run that. So we'll close this and we'll open up RMSVEL. I'll typically need to load in the VT-cube file, which I just generated. And now what I have is a bunch of constant velocity stacks, or constant velocity migrations, starting here at 1,500 meters per second. And I can press the arrows here to go faster, or use the arrows on the keyboard to step through all of my constant velocity migrations. So we've got a bunch of constant velocity migrations we can see here in the central panel. On the right side, we've got a vertical semblance calculated at this specified trace here. On the bottom, we've got a horizontal semblance. At this point in time, it's just calculated on the floating topography here. Since there's not much data, that semblance doesn't look reasonable. So first of all, we'll just point out that you can pick velocities on the vertical semblance if you want. And you can specify a starting point, let's say. We'll start at CMP 50, or trace 50 in this case. And let's say I want to go forward 50. Now here I'm looking at the vertical semblance at this location. I can go ahead, use this icon here to start picking velocities. I could pick velocities on this semblance if I like. I could change the scales here to fill more of the screen, etc. And I would right-click to complete that. So now I've picked a function for this location. I could then go forward to the next location and pick velocities there as well. I'm still in the picking mode since I haven't chosen any other mode, so I could obviously pick much tighter control on that if I wanted. For now, I'll just do this. So I've specified a velocity function at a couple different locations here. I could continue forward, picking a velocity function at each of these locations across the section, and then I could build a velocity field from that. That's one option for picking velocities. Another option is defining horizons on the section and picking velocities on horizontal semblance along that horizon. So in order to do that, we'd have to change the mode to horizon mode. And then we can go to a velocity that we see some reasonable looking data. So I'll scan to a, let's start picking velocities. Let's pick a horizon first of all here. I'll just do this roughly to get an idea of the functionality. And now we can see that we have the horizontal semblance along this horizon. And using this, I'm still in the picking mode. I can then actually assign a velocity across the section by picking along this semblance. Again, I'll just do this quickly. I'll right-click to complete that velocity. So now I've assigned these velocities along this horizon. I could then go to a faster function. I can change to a location where I can see a coherent event. Go to the picking mode and pick along an event in the seismic I see here. It doesn't need to be exactly on the horizon, although probably it makes more sense to do that. But it will still calculate a semblance along the horizon that you've picked. And then I can now pick velocities along this semblance in the bottom panel. Again, I'll do this fairly quickly, just for demonstration purposes. You can add in as much detail as you want here. Sometimes on the edges where we just have migration swings, we'll just continue that out to the edge, get close to the edge, and then right-click to complete that. I'll pick one other horizon here. I'll start picking it here. Again, I've crossed horizons here slightly, but this is just for demonstration purposes. I'll right-click that. And again, you can see, in this case, we have quite a strong semblance along the horizon for most of the section. In this case, we can add in some detail. Again, I'm doing this fairly quickly. Right-click. So this is the methodology for picking velocities on a horizontal-based semblance. And you have both options at your disposal. In this case, I'm going to load in the velocities that I've already picked previously so we can see what a completed section would look like. Here I've reloaded this to put the velocities that I've picked previously here. Now we can see that we've got several horizons defined and we've got velocities assigned to them. The color of the strands here as we go across represents the velocity that's been assigned to them. We can click on any one of these horizons here to highlight them, see the semblance along the bottom. I'll click another one here to highlight that one. So once we are satisfied we've picked a reasonable number of horizons to define the velocity field. This is still somewhat sparse, but we'll generate a velocity field from this anyway. We would go up to Build Display, and we want to build a velocity field from these image panels. So building from the image panels, we'll build it from the velocity field you specified from the horizontal semblance. If you build a velocity field from the semblance spectra, that's referring to the vertical semblance here. So in my case, I'm only going to use the velocities I've picked on the horizontal semblance, so I will use that first option. and this is my velocity field. I could apply some smoothing if I wanted to that velocity field. If I'm comfortable with that velocity field, I can proceed forward, or I can go back to display the say y again to modify some of the horizons or some of the velocities. If I want to go back to display the velocity field again, I can display velocity field from image panels. One thing to point out, these horizons do not need to be continuous all the way across the section. They can be partial horizons. Once we're satisfied with that, we can go ahead and extract a seg-y image to generate a composite PSTM. And we'll do that here. And this is an extracted seg-y as a composite image of all the different constant velocity panels we have. Now we're ready to go ahead and actually use that velocity field to run a pre-stack time migration.